So hi, everyone. We're just gonna go ahead and get started. Hi, my name is Anna White. And this is,
I'm Maria Alfaro.
we've got Janet in the back. We've got Jonah up here. And we all work here in the Statistical Consulting Lab. And we are all GAs in the Applied Data Science program. And so today we're gonna talk about exploratory data analysis and do a little walkthrough where we kind of explain some stuff. You should have gotten an email with the notebook that we're going to be looking at today. And so I'm going to be using the Anaconda Cloud. So I went ahead and signed in. So I went ahead and signed in, and once you sign in, it's going to look something like this. So all you have to do is go down here and press Launch Notebook. And that's going to take you to it. Yeah. Up here, the Jupyter Lab, where we're going to be working today. So when you open it, it'll probably look something like this. So if you have downloaded the workshop and the data to your personal device, you can go over here and click upload, and you should be able to select it and just upload it right here. So I went ahead and have this opened. And just a quick note, over here is the Anaconda Assistant. This is basically like ChatGPT, and it can be really helpful as you write code. So this workshop is not a code tutorial. We're really going to be talking about exploratory data analysis techniques and what you should look for as you explore your data. But if you do need help writing code, we have some code in here for you to look at and maybe steal it for your own purpose, because why not? But if you do need help, you can ask the Anaconda Assistant. It works pretty well. So I already have the data uploaded. So yeah, make sure you have the data set. It is called mtcars.csv. Make sure it's right here, right next to the workshop, and then it'll work. Okay, perfect. So exploratory data analysis is vital to any project working with data. Once you have data, before you can start modeling or doing any type of statistical analysis to answer any questions you may have, first, you should explore your data. And when you explore your data, you're looking for any trends or patterns that might pop up to better inform your analysis. And as well as any problems or inconsistencies with your data. This is very important. We're going to go through and show you how you can look for those. And if you encounter some of them, what you can do to fix it. And so this is a step-by-step tutorial. We're really going to try to show you where you should start, where you should end, and everything in between. Once you have data, let's load it in and start looking at it. And so really important note, something that we learned here in our classes as we work with data is your explorations need to be geared towards your future representations. And this is really important. And what this means is that, let's say you're doing your thesis and you collected some data and you have it with a research question in mind. So as you explore your data, you should be thinking about the questions you want to answer and help that gear you your explorations towards your future analysis. That is the best way to be productive and to answer those questions. So, and then we also want to stress that EDA is going to look way different for different types of data. So this data is a pretty simple data set that has some categorical and numeric data that we're going to work with. But if you were working with time series data or data with images or even text data, the steps you might do are going to look way different than this. So this is just a basic tutorial to help get you started. And time is on factor here. So all of our analysis is going to be independent of time. And so anyway, and this notebook is about cars. So we'll get into that. So just some steps for exploratory data analysis before you load in your data. There's some things you need to know. First of all, what is your data? Maybe you collected it yourself. Maybe you downloaded it from Kaggle or somewhere else. But usually when you download data, like on Kaggle, it'll have something called a data dictionary. And this is going to tell you what all your variables are and how they were collected, what units they're in, things like that. You should know this before you start working with data. And also you want to know how it was collected. And if you collected your own data, hopefully you'll really know that. That'll be really important. You also want to know the meaning behind all your variables. And yeah, who collected it, what was the source. And so that's all very important to know before you even start loading in your data. And once you have loaded in your data, you should be exploring it. How many observations, how many columns, how many variables do you have? What types of variables are those? Are those numeric or categorical? If you have numeric variables, are those frequencies? Are they counts? Are they averages? This is really important to know and can change your analysis. Also, are your numeric variables interval scale or ratio scale? So what this means is that interval scale is going to be something like temperature, where there's no true zero. So for example, you can think of it like temperature, because 200 degrees is not twice as hot as 100 degrees. That doesn't really make sense as compared to a ratio scale. Something like money would be ratio scale. If I had $200, Maria had $100, I would have twice as much money as her. So that's just something to keep in mind with your numeric variables. And then also for your categorical variables, are they nominal or are they ordinal? So the difference here is that ordinal implies that there's some type of order in your categorical variable. This could be like if you had a survey and it was select, confident, somewhat confident, or not confident at all. There's some order here. They're not independent of each other. While something nominal could be like sex, male or female. There's no implied order there. So these are things you should keep in mind and know before you get started. And so once you do get started, we just wrote out some general steps of things to keep in mind, and we're going to go through each of them. But so when you're working with data and something like Python or R, you should figure out what libraries we use them. You're going to be using, go ahead and import them. Load in your data and check if the data is loaded correctly. We'll show you how to do that. You should clean your data and check for missing values, and we're going to show that here in a little bit. And then after that, and after you know that your data is consistent and you know what's in there, you should start exploring your data. So explore the numerical variables, explore the categorical, look at relationships between numeric and categorical. This is very important and can tell you a lot and help inform those representations for later. And also, what about analysis using statistical tests? And then assess your modeling goals. What did your EDA tell you for the future of your purpose of your data? So Marie here is going to go ahead and take over and start with getting started.
All right, so this dataset is a public dataset. We got it from Kaggle, but it's actually an R dataset. So if you're familiar with R, this is one of the datasets that are loaded just like as a standard package. So for this, we have, I'm gonna go ahead and open it with here. This is how the dataset looks like. And for the purposes of these workshops and illustrating everything that we're gonna do, it's a pretty simple dataset, not so many columns, not so many rows, just to have everything like very clear and like keep it simple. So we have these variables right here. We have the model, MPG, cylinders, divs, and so on. These are our variables. And then let's scroll down. It seems that we have 33, but the first one is a title. So in fact, we have just 32 rows of data, right? So when we load our data, this is something that we need to check. So we're gonna go ahead here. And like I said, number of observations is 32. The number of columns that we have in our data are 11. And here are some of the variable names and types.
Yeah, for example, miles per gallon. If you get like 20 miles per gallon in your car, that's twice as much as somebody who gets 10 miles per gallon, which would be pretty bad. But anyway, so that would be ratio scales. And then something like number of cylinders here is categorical, because you don't just have a continuous number of cylinders. It's a different category when they build your car, but it's also ordinal because 4 cylinders is more than 2 cylinders, but it's still less than 6 cylinders. So yeah, those are all of those different types for each of these variables. And then yeah, so real quick, so everyone knows MPG is miles per gallons. Then we have number of cylinders, displacement, gross horsepower, rear axle ratio weight, quarter mile time, the engine type, transmission, so it's automatic or manual, and the number of forward gears. So yeah.
All right, so now that we know how our data is looking like and we know what variables we're going to be working with, we can go ahead and import some necessary libraries. And to run code here in the cloud, we can hit this button bar here, or we could also do Shift and Enter. And yeah, so as you can see, we just run this line right here. We imported some libraries, pandas, NumPy, and matplotlib, since we're going to be doing some plots and stuff. And then we're going to use this code right here to import our data set that is in the CSV format. So we use pandas.readCSV, and here it goes. Now we loaded it, and we want to see if our data set was imported correctly. So we use this command .head 10, and this is going to show us the first 10 observations of our data. And as we can see right here, we have the model, miles per gallons, cylinders, and so forth. So we see that all of our columns have been imported correctly, right? This is very important. Then if we scroll down, we can also check how many columns and how many rows our data has. For our example right here, it's pretty easy to see, like the number of columns is correct. But when we are dealing with more columns, this is something important to take a look. And yeah, effectively, we have 32 as the number of rows and 11 as the number of columns. So we're good with that. The data was imported successfully. And now we can go and try to clean it before exploring it. So what we're gonna do now is we're gonna check how many different values each column has. So we run this unique function, and we see that the model has 32 unique values, which means that each observation has a different value for this category. So since it's unique, it's not going to be relevant for our analysis, so we can go ahead and drop it. And if we need to go back to it and see something, we can see, but like for the purposes of data analysis, these ID variables, we're not going to need them. This includes something like, for example, if we're dealing with customer data, the customer ID, since that's unique for everybody, that shouldn't be computed in the analysis. So we're going to go ahead here in this part, and we're going to drop it, and we're going to see if it has dropped correctly. So now we can see right here that the model of the car is not there anymore. So we have dropped that variable, and now what we can do is the next step, checking for missing values. This is very common when dealing with data, and there's like a lot of questions about how to deal with them. Should we drop them? What should we do? You know? So yeah, there is obviously two options when we check for missing values. Either you have them or you don't. If you don't have any missing values, well, this is great. This is the perfect case scenario, and you can just go and start your analysis right away. But if you do have missing values, what do we do? So we have two main options, and either we can just drop them and not consider them, but this is not advisable in like some cases. And then the other option that we have is imputing. And this is like knowing how our data is looking like, maybe try to put some values for these missing cells that we have that make sense to keep the properties of our data. So how do we choose what to do? We need to take into account two main things, actually like several main things, but yeah. First of all, how many missing values do we have? It's not the same if I have only one missing value right there in a data set that has thousands of observations. It's probably not gonna have a very big impact, right? But if we do have a lot of missing values, then that's something that we really need to take care of. We don't want to like, if you have, I don't know, 40% of a column that is missing, we don't want to drop all of that. We are losing a lot of information, valuable things that our data can be telling us, because we can have like all the columns complete, and this column maybe is just missing data. So we're dropping all of the other columns for nothing, you know? So yeah, in general, this depends, you know, what is considered a low proportion of missing values or moderate or high. It really depends on how many observations you have, because if you have 10 observations, one that is missing is really gonna make a difference. But if you are dealing with like, I don't know, 30,000 of observations, if you have maybe like 2%, 5%, it's not gonna be very much. So it really depends in each data set, but yeah, if the proportion is very low and you have a lot of observations, sometimes you could consider dropping them. But if this is not the case, we should consider some type of imputation. But imputation is not something that is that easy, you know, like we don't want to be just adding some random numbers to our data, and then this is going to compromise all of our results, right? So we don't want just to put a number just to keep the number of values that we want to have. We need to be very careful. And the very first thing that we need to check is the missing data pattern. So we need to try to see if these missing values have some type of relationship with the rest of the variables. Like, are these missing values missing completely at random, which means these missing values are independent of observed and unobserved data. So like, for example, we're completing a survey and somebody just like skipped the question because like they double clicked. They didn't realize they didn't fill that up, and that's why it's missing. So that's completely at random. The missing and random are values that are related to observed data, but not to the unobserved data. So maybe we have, I don't know, a variable that is the age or something like that. And then we're asking about work experience and we have some 15-year-old people, maybe they don't have work experience and they are gonna tend to skip this question. This is missing at random, but this is not completely at random because we know kind of like the factor that is leading them to miss this question, or at least we can hypothesize it. And then we have missing not at random, and these ones are related to unobserved data. So something that we are not taking into account that is affecting why our data is missing. And there are like some couple of tests to see that, but this is like a whole world of analysis and its own stuff. So we don't want to like deviate from the exploratory, but we're gonna show like a few examples of like how to be careful with it to be ready like as a pre-process step to get to the exploratory data analysis. So we're gonna go ahead and we are gonna check how many missing values we have. And this is the proportions of missing values. So we have here for this, we have 12.5%. And we have here another variable, transmission, which is automatic or manual, 6.25%, right? And in a data set with 32 observations, we maybe don't want to drop them, right? So we can run this plot to try to see if there's a pattern. And in this pattern, what we mean is like, are the columns, the rows that are missing are the same for every column? And we can see here that this is not the case. Right here, we have the different variables. The black colors indicate like the ones that are complete, and the white is the ones that are missing. So we have 4 missing for this, and here we have 2 missing for the transmission. So we're gonna get started just with the transmission. We have 2 missing values. So we want to show you how to like 2 different options to deal with them. First thing that we're gonna do is we're gonna create a copy of our data right here, because this is not actually what we're gonna end up using it for our analysis. So this is just an illustration. So let's look at the shape before imputing. We have 32 rows and 10 columns right now. And now this is the code that you can use to just drop them. And then you can look at the shape again and you see that now the number of rows has been reduced to 30, right? So as simple as that if you choose to drop them, but sometimes you may not want to drop them. So maybe if we want to impute, we can consider simple methods because the percentage of missing values was very low. So some simple methods include mean, median, mode, or if we have a uniform distribution, maybe a random imputation, just like put something. In this case, it's a categorical variable, so we don't have a mean. And then to decide which one to use, what we can do is maybe look how this variable is distributed. We have almost 60% of our values being manual transmission, and we have 34% being automatic transmission. The rest are the missing values. That's why this doesn't add up to 100. So we see that like clearly there is more cars with manual transmission than automatic transmission. So since the number of values that are missing is pretty low, one of the options for simple imputations is just go ahead and impute the one that is repeated the most, because it would make sense like for the data. But again, this is a simple imputation. If you want more complex methods to take into account other variables and the relationships, there are other things that we can do. But like I said, that's like beyond the scope of the workshop. So we have used this code, fill NA, to complete the variable with the mode. And looking at the counts again, now we have 65% being manual transmission and 35 still being, 34 still being automatic transmission. So it hasn't changed much, and this is what we are targeting, something that doesn't change, that it looks roughly similar in the beginning and in the end. And now we have for this variable, our numerical variable, right? So the first thing that we're gonna do, I'm gonna show you like an imputation, one of the simple methods, for example, the mean. Remember that we had 12% of this variable that was missing. So this is quite a bit. So we see here that there are some variables that have been read as numbers, but in fact they are objects. So we want to turn them into objects using this code right here. And then what we do Right now, we read that again, and we want to describe our data set to look at the properties of our variables before the imputation. So we're gonna be looking at displacement, is the one that had the missing values. So we see, for example, the count, we have 28 values. We have a mean of 227, standard deviation of 119, and minimum value of 75, and so on. So we do want to keep this the same after we impute. And this is like why doing this is relevant. And one other thing that we do want to keep the same is the distribution. So one simple way to look at it is to create the histogram like we did here. So look, there's like, for this bean, there's like a lot of observations, roughly 11, and then it tends to like go up, up, and then down again. We want to keep this shape, right? So now I'm gonna show you why these simple methods, like the mean or the median, sometimes are not the best choice. So suppose we're gonna use this code right here to impute the missing values with the mean. And then we're gonna look at the description again, which looks pretty much the same, though when we go to plot the histogram, look how much it has changed. So now our data has changed totally in the distribution, and then this is gonna affect our results. Like we don't have the same that we had before. We have changed everything, like we have added the observations to the mean. This is gonna affect the analysis. Thus, when we do modeling, it's gonna affect our results, and this is not what we want. This is gonna be misleading. We're gonna get wrong answers for everything, so we don't wanna do this. Thus, what I'm gonna show you, like something here, we can consider methods such as mice imputations, which is using multiple chain equations, which basically what they do is try to use the other columns that are complete to predict what will be the value that is missing in the column that has the missing values. So I'm just gonna show like a very, very simple example and a basic case of how we can achieve something like that. And we can look like maybe, since this is a numerical variable, if it is correlated with something, it might be a good choice to like, maybe as this variable is increasing, the other one is increasing as well. And if the correlation is strong, then a variable that is completed may be telling me something about the other one. So this is something that we can use to impute. So looking at the correlations, we are looking at this variable right here. We want to find something that has a big correlation with it. And right here, we notice this 0.87% of correlation, which is pretty high. So one thing that we can do is try to use, let's check, the WT variable to predict the values that are missing for this variable, right? So I'm not gonna get into the whole details of this code, but basically we are taking all of the values that are present for both as our training set, and then we are predicting the ones that are missing. That's what we do right here. And when we look at the shape, now we see that we have completed the data, and now looking how many values are missing in each of the columns right now, we have all zeros. The imputation was done successfully, so now what we should do, like I was telling you, check if everything has remained the same. So we're gonna go right here to see how the distribution of the variable that we imputed looked before and how it's looking after. So obviously the count, we are expecting it to change because we just added new values to it. Then we have a mean of 227. Here we have a mean of 232. It's not bad, right? Standard deviation of 119, and now it's 124. Still not bad, pretty close. Minimum value of 75, here 74. First quartile 120, this is still 120. Here with the median, we see something that may call our attention. 196, and then it goes all the way to 241. So this is something to be careful about. So we need to keep exploring. And then the other two are almost the same. So pretty close again. Another thing that we can see is the correlation. Since we have used the correlation for this analysis, we need to see for displacement. Let's look. This is before. This is after. They look pretty much the same, so this is a good sign. Last thing that we can see that was the problem that we were having before. We had our initial histogram looking like this. And remember how when we imputed the mean, then this beam right here went all the way up, changing the distribution. Now with this method, see how the distribution is kept. So this is what we really want when we do imputation. We want all of these characteristics to be kept. So I hope this helps somehow a little bit to like how to deal with this missing values and everything. It can be pretty challenging, but yeah, if you're ever doing research and you have questions about that, we're more than happy to help you. There are a bunch of methods that we can use, and this is just like a very simple examples. And now Anna is gonna take over and she's gonna take you to the data visualization part.
Okay, thank you, Maria. So now that we have data that has been fully imputed and we know it's read correctly, and we know what all of our variables mean, next we're gonna start visualizing this data. So this is something I love to do, especially if you are working with categorical data like survey data. This, in my opinion, is by far the best place to start. And these are just frequency tables. Really, these are kind of like, we'll get into pivot tables kind of in a second, but this is going to give us the number of counts for each category of our categorical variables. This can definitely tell you if you're seeing anything where you have a lot of this observation, not a lot of this. So we can see for cylinder and then VS, this is transmission and then gear. Notice how there's not a lot of cars in this data set with 5 gears, but there are quite a bit with 3 and 4 gears. So just things like that, if I was doing an exploratory data analysis of this, those are the things that I would be thinking about. So next, we're gonna look at some bar charts. And this is gonna be a better way to visualize those frequency tables, is to look at these charts. And so these are pretty simple, but they can tell you a lot. Again, it's the same information we just saw earlier. We have the count and then the type of the categorical for each of these. And just a little bit about this code. So we made this in matplotlib, and we also use Seaborn. Sometimes things in Seaborn just look a lot nicer than Matplotlib, which is why we use it. And so if you ever want to, instead of creating a couple of plots like independently, if you want to do them all at once, you can go ahead and adjust your figure size and say how many subplots you want. So we wanted 4, so we did 2 by 2. And then this is right here we wrote a loop. So for I column and of from car and all of the object variables and their column names, go ahead and plot it, is basically what this is saying. And this is a really great way to do this. If you asked me right now to write this, could I from memory? Probably not. But that's why we use things like the Anaconda Assistant or ChatGPT. Can be really helpful in writing something like this. And so, yeah. Just again, though, this is kind of like those frequency tables, but there are some other methods that we'll get to in a second. And so next, this is just, we did basically the same thing, but for our numeric variables, and we want to look at a bunch of histograms, which is my preferred method of visualizations, very much where I start whenever I'm visualizing anything. And so histograms are great, and these are for numeric variables, and they're going to tell you a lot about the distribution of your data. So notice over here that for miles per gallon, this is not quite symmetric. This looks like it has a tail on the right side, so we would say this is about skewed right. And notice this is also considered bimodal because it has 2 peaks, right here. Little language for you. And then we have displacement, horsepower. You can see that's also quite skewed as well. This one's kind of funky. And we have this one and weight. Notice over here, this is when they're all at the same level right here, that's kind of a uniform distribution. So for those different counts, it stays about uniform until over here. And then we're getting way more in these categories. And then see over here, we have some observations who are even up here, all on their own. And you can't quite get a good look at those in histograms. So then we might make something like a box plot, which is in this data or in the cell. So see, the box plot can tell you a lot, like there might be an observation up here that's an outlier. And then they can also tell you basically what a histogram tells you, but more specific on the outliers, and you get a sense of that spread. And while this is great, this can tell you a lot. This is a great place to start with your data, but it's, in my opinion, when you're exploring, it's not enough. Especially if you want to do some type of analysis with your categorical and numeric, you really want to get more in depth. So what we like to do is make some plots where we're taking into account both the categorical and numeric variables. So over here we have for transmission, types, so manual or automatic for each numeric. And so just some things, as I'm looking through these and I'm reading them, some things I would notice. It looks like right here, this line represents the median value, in case you know. So the median for miles per gallon of automatic is lower than for manuals. So manuals are getting much better gas mileage, something to keep in mind. And then over here, the median for automatic is higher for horsepower, but there's some outliers up here, kind of pulling this up over here for manual. And then displacement too, you can see those differences. And so, yeah, this is a good thing to keep in mind. Well, you know, sometimes automatic's higher than manual, and this can help kind of direct your analysis and also keep in mind your future representations. And so you can even go further, like with gear. So we can see miles per gallon for gear. Notice how all of these medians are not even that close to each other. And over here for displacement as well. So as you go through, take into account some of these observations. This is the analysis part. What are you seeing? Not just making some pretty plots. And yeah, this is another great way. As you get more data, bigger data, more categories, you might want to consider other visualization methods because this is going to look a little crowded. This is a small data set, so you can tell a lot. But as you have more data, it might not be as easy. And something else you can do is also consider 2 categorical variables at once for each numeric. So these plots. So these plots can tell you a lot. They are a little confusing though, and they still kind of work just because our data set is small. So we have, and notice something I'm really looking for, I'm looking at this is, in this data set, there are no, I think one was automatic. So there are no like automatic transmission, thank you, with 4 gears. So just some things you can tell like this. Personally, if I was doing a report, I wouldn't report something that looks quite like this. It's a little messy and hard to read. So that's something to keep in mind too as you do your explorations, that sometimes you need to think of limits. And if you have trouble reading it, I bet your audience, whoever they're going to be showing this to, is also going to have trouble. And so you can also look at those summary statistics. You can do group by, which works great. But as you can notice here that when you have a lot of columns, this is 48 for every single numeric variable, it gets really crowded. As well, same for gear. So what you might want to do instead is be a little more specific and say, I want to see group by gear, but I only want to see horsepower. And so here you can see that the horsepower is very low. The average horsepower is a lot less for cars with 4 gears than cars with 5 gears. So that's some things also to keep in mind as you're going through with this. And then, yeah, if you just want to see all at once, you can just do describe, and you can get those counts, mean, standard deviation, and then that 5 number summary for every single one of your numeric variables. It's not going to show you the category. And you can also do some things all at once. So this is, sometimes we call this like a pairs plot, but this is a great way to, take a second to go. This is a great way to look at all of your numeric variables all at once and in pairs. And so we have these same histograms that we saw earlier, but really when you're looking at this, you're looking for those things that are similar. So like notice right here, miles per MPG and displacement have quite a linear, negative linear relationship going on here. And so as you go through, these are just some things to keep in mind. Even this looks curved. So just some things to look for. In general, if you are going to be modeling, and we'll talk about this in a second, you don't want your predictors to be correlated with one another. But if, say, miles per gallon was your predictor, I would go through and be like, oh, well, maybe I need a quadratic term here. This looks curved. Oh, maybe, just a linear term here and there. So these are some things to keep in mind to help you gear your explorations towards those representations of your analysis. And so next, Maria is going to talk some more about some analysis you can do.
So yeah, once we do this visual analysis, there are a couple of things that we can observe. But then how do we know if this is actually significant to conclude, oh, okay, these 2 categories are actually different? So there are a couple, actually a lot of statistical tests that we can use to analyze our data. And this is why, like what Anna was saying, like the interpretations of the box plots and all of the analysis, mainly even the crosstabs, TUI tables and everything. When we observe these things, maybe we want to know, is this actually significant in terms of statistics? So, for example, there are, like I said, many things that you can do, but one example that you can see, for example, she was talking about how the gears and the transmission had some disparities right there, like there were no manual transmissions, no automatic transmissions with 3 gears and no manual transmissions with 5 gears. Oh my god. So yeah, let's see. Is this really statistically significantly different? So one thing that we can do is a chi-square test of independence. And basically what we're trying to do here is to see if there is an association going on between 2 categorical variables. Like, does one categorical variable tell me something about another? So yeah, for this, we're basically using this two-way table that we have right here, and we generate expected counts, and then we compare how they look with each other. So we basically run a statistical test. If you're familiar with p-values, we're gonna obtain a p-value for them. And then if the p-value is less than 0.05, we always conclude the alternative. So we reject the null. And if the p-value is greater than 0.05, we will not reject the null. So we can run this test and see what happens. So right here, we see that we're getting a p-value of it's 8 to the -5. So this is 0.00008. So definitely less than our significance level that was 0.05. So what happens? Now, we said that if the p-value was less, we're gonna conclude the alternative. So what this test is saying is that there is enough statistical evidence to conclude that there is an association between these 2 categorical variables. So in fact, gear and transmission are associated based on this test. And this is really helpful. Sometimes we see this a lot when people do surveys and they work with categorical data, and they just have, like, you know, agree, disagree, or something like that, and then like different categories, for example, freshman, junior. This is a way in which you can test if one variable is telling me something about another variable, if they are associated. So this is pretty useful. Then I don't know, let's say we want to take a look at something like more numeric. And I was talking about how the median was different for different categories of gear, right? So were these medians really that different to be considered statistically significant? Significant. One thing that we can do is a Kruskal-Wallis test. And this basically, what it is saying is that there is no difference in the median of the categories for a basic, one numerical variable. So we are looking at miles per gallon across the different gears, versus the alternative in which we're gonna test that there is a difference in the median miles per gallon across at least one pair of gears. So we can run this test. And again, we're getting a p-value that is less than 0.05. So in fact, we can conclude that there is a difference in the median MPG across at least one pair of this. So this is something that we can do to claim statistical significance when we are doing our exploratory data analysis. And like I was saying before, there are a bunch of tests that we can use, but you may have heard maybe before about the t-test for means, right? That's pretty common, a lot of people use that, but what happens? These tests have assumptions, and if we don't check for them, then our results are not gonna be trustworthy, right? So for a t-test, we need a normal distribution. And then when we were looking at the histograms, did we see any normal distribution? No. So we can't use this test. And this is why we need to be very, very careful when we're doing this analysis, because when we get to these tests, we're going to use the plots that we created before to try to see if it's actually doable to apply these statistical tests. So for example, we have also proportion tests. And for this proportion test, they assume that the observations are independent of each other, which is what we tested with the chi-square test of independence. So we need to make sure that these assumptions are met before we apply our tests. And yeah, like the exploratory data analysis tells us basically which tests are doable for us to apply. Some other examples, we have analysis of variance, Wilkinson rank-sum test, the sign test, and like we could keep going like forever, saying like statistical tests that we can run, but this is like since our data doesn't meet the assumptions for these types of tests, there's like no point right now to try like transformations or stuff like that to try to force them to meet these assumptions. But yeah, there are ways in which like if your data doesn't meet the assumptions, you can transform them to try to apply them, but this goes beyond what we are covering today. And now that we have given some examples of how we can run the data analysis, we can move on to defining our modeling goals. So for this data, one thing that we could do is predict the number of miles per gallon. And then here comes another thing. We need to choose a model, right, to make our predictions. And in the same way that statistical tests have assumptions, so do models. So when we choose our model, we need to be very careful, check what are the assumptions of the model, and then continue the exploratory data analysis to try to see if these assumptions are met and if it's doable to apply this model. For example, we're presenting right here that maybe we want to apply multiple linear regression. And this requires no multiple linearity. So as part of the exploratory data analysis, we need to check if multiple linearity is present between the predictors. One way to do it, you can look at the correlation matrix that we were looking at before, but another thing that we can do is look at the variance inflation factor, which if it's less than 1, it means that the variables are not involved in multiple linearity. If it's roughly between 1 and 5, it means that it's moderate multiple linearity, and if it's greater than 5, there's a lot of multiple linearity. So as we can see here, we have 6, 7, 5, we have an 8 right here. So all of the variables are at least moderately associated with this multiple linearity. So this is a problem. And then maybe this model that we were thinking in applying is not gonna suit our data just because we don't meet those assumptions. So either we need to try to treat this, deal with them in some way to be able to apply the model that we wanted, or we would need to change our model. So this is basically what Anna was saying, that this has to be geared towards what we want to do. Now, if we like got into like talking of how like to fix this and try to meet all of these assumptions, this could be like the topic for another workshop. But yeah, we just wanted to like try to give you an overall idea of like what are the initial steps for getting into this. And then one other thing that you can do that is pretty popular is trying to assess the feature importance. So once you know what you want to do, that we said, for example, we want to predict the miles per gallon based on all the other features, we can try to see and run some type of model. For example, we chose the random forest to try to see what are the most important features or the ones with the greatest association to try to predict this response. So we can run this code right here. We see X, we're gonna get the predictors, we're dropping just the variable that we have. Y will be the one that we want to predict, and we're gonna run this little model, but this is, instead of modeling, we're just doing an exploration. And then we print an image that assesses the feature importance. So we see that for predicting miles per gallon, the one with the biggest bin is gonna be the one that is the most important in predicting it. And then thus, the features that are like with like this that is not really important, sometimes maybe if you have too many features, you don't want to consider them, right? So these are, yeah, mainly the most important steps before getting started with modeling, how to get to know your data, explore it, and then once you are all set up and you take care of all of this, you can go ahead and start. So yeah, that's pretty much all we have for today, right?
That is all for today. Just remember that, once again, your exploration should be geared towards your representation. So keep whatever question you want to answer, know that before you start exploring, keep that in mind as you move on, and hopefully it can guide your analysis towards something. So yeah, thank you. That's it. We can definitely take some questions, and then also, if you would like, it is optional, but we do have this QR code you can scan to do a little satisfaction survey. You can also request future workshops, or we love feedback, so you can do that, but if not, yeah. Thank you so much. And does anyone have any questions? Anything we talked about, or, yeah.
Yes. Can we have access to the notebook?
Yeah, I did email it out
Yeah. Okay.
to everyone, so you can just can tell your email in a second. I'll make sure that you get it. So thank you.
Yeah, thank you for joining us today.
Thank you so much. You can chat us too if you're on Zoom.